In our next section, section 8.6, we're going to talk about trigonometric ratios. In trigonometry, it is a branch of mathematics that is based on the properties of similar right triangles. So in order to use all of this stuff we're going to talk about in trigonometry, you must have that 90-degree angle, that right triangle. So if you don't have that 90-degree angle, you can't use this information. And they have to tell you that it's a 90-degree angle. There has to be a box, or they have to tell us it's 90 degrees somehow. We can't just assume it's 90 degrees. So if we know we have that 90-degree angle, then we have three basic ratios here that we can use: sine, cosine, and tangent. And for an acute angle in a right triangle, we know that the sine of that angle is the opposite side over the hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And there's a lot of ways people remember this. The way I remember it, for sine we have some old horse caught another horse taking oats away. That is how I remember. So katoa. Okay? So we can use those three ratios when we are solving some problems involving right triangles. So if we look at our example, it says express each ratio as a fraction and as a 4-digit decimal. So if we're looking at the sine of t is up here. Sine is opposite over hypotenuse. We'll write that over here, opposite over hypotenuse. So if I look at t, the opposite of t is 12, and my hypotenuse of the triangle is the long side, which is 13. And when I write that as a decimal, plug it in my calculator, if I'm looking for a 4-digit decimal, I'm going to write 4 places after my decimal. So I have 0.9231. Okay, cosine is adjacent over hypotenuse. The adjacent to t is 5, and the hypotenuse is still 13. When I write that as a decimal, 4 digits after the decimal place, I get 3846. And then tangent is opposite over adjacent. Opposite we said was 12, adjacent is 5. 12 divided by 5 gives me 2.4. Okay, then it wants me to look at the sine of r. So I look at r here. Sine is opposite over hypotenuse. Opposite of r is 5. Hypotenuse is still 13. 5 over 13, we already typed that in, it's 0.3846. Cosine is still adjacent over hypotenuse. The adjacent of r is 12. Hypotenuse is 13. 12 over 13 we said was 0.9231. And then tangent is opposite over adjacent. Opposite of r was 5, and adjacent was 12. 5 divided by 12 we said was 0.4167. Oops. Okay, so that is practice getting our ratios for sine, cosine, and tangent. And remember, we can't apply the sine, cosine, and tangent to our right angle s. It has to be an acute angle. The next way we can use sine, cosine, and tangent is if we know the measure of the angle that we're looking at. So if we look down here at angle A, we know that this right here is 40 degrees. So if we know the measure of the angle, then you can use the degree mode on the calculator, and that's going to give you the decimal value for sine, cosine, and tangent. So if we try plugging it in, we have sine 40 on our calculator. That is going to give you 0.643. Okay, so if you do cosine of 40, that is going to give us 0.766. And tangent of 40 on our calculator gives us 0.839. Then if we want to know what B is, remember we know all three angles inside have to equal 180. So if we take away 90, that leaves us with 90 degrees left, but we know we're taking away 40 more. That means we have 50 degrees left for angle B. So angle B is going to be 50 degrees. And then we're just going to plug it in again. So we have sine of 50, cosine of 50, and tangent of 50. We can plug all three of those into our calculator. For sine of 50, we get 0.766. Cosine of 50, we get 0.643. And tangent of 50, we get 1.192.